some of this stuff is going to feel like it's a long time ago, even though it's a couple weeks only. So write each expression in radical form. Remember, exponent over root. What's that mean? What that means is when you see it in an exponent like this 2 is my exponent, and the 3 stands for the root. And you're like, root. Now that sounds familiar. Remember, the 7 will be underneath. The root is the little number that goes out here. So it's, it's a cubed root, not a square root or something else like that. And then my exponent just will go on the outside of that. Now some of you may say, could I put the 2 here? You can, but sometimes if we get multiple things working, that might not be such a good idea. We'll talk about that when we get to one of them. But that's how these are going to work. If I go and do it with a number, it works the same way as it did here or here. I'm going to make a radical. Whatever the big number is, I'm going to put it underneath. Whatever the number on the top is going to be my exponent. And whatever the bottom number is going to be my root. And if you're wondering, well, what if I get those mixed up? Just keep reminding yourself it's just like the alphabet. Exponent comes before root, E comes before R, and it'll help you keep it straight. So the numbers are all work that way. Well, what about when I get to the variable stuff? Okay, no different. So like if I get to number 5. So I'm still going to go radical style here. But here's where things would be a little different if I was putting the exponent on the inside. Still going to do my root. Still going to do my exponent. If I were to put the exponent on the inside, I'd have to have parentheses around my 7k. So if you wanted to write it the other way, if you just wanted to do this, you could. Okay? But the parentheses would have to be there. Because if they're not, then it's not quite correct. And that's all we're doing. You're like, man, I don't remember this being this easy. It was then, still is, root, exponent. Okay. So the first part will just be flipping them that way. The second part does just the opposite. Write each expression in exponential form. So when we get here, I'll keep those up. There we go. Now we're doing just the opposite. Now, here's the thing that gets tricky with this, though. We're going to take a look at both of these two. If I don't see an exponent anywhere, what exponent is there? 1. So if I don't see an exponent, I'm going to go ahead and I'll put one in. And now I'm just going to work this backwards. So whatever number's underneath is going to be my big number. And then it's exponent over root. And I've got it into an exponent form. And yes, the order matters. I can't do 6 over 1. It's got to be 1 over 6. So I can see how that works. Now on 10, okay, we just got done saying the exponent's 1. What if I don't see a root number? No, but close. 2. Because you think about it, we normally call it a square root. Things that are squared to the second power, so squared. So this would be 5. And then what am I going to put for my... Oh, some of you are ahead of me. This is good. Exponent over root. You guys might have the whole packet done before I get to the next page. Okay. Okay, those two guys are pretty straightforward, so I'm not going to worry about 11 and 12. Okay. And then I just had another group going back to radical form again. I'm not quite sure why I added more in radical form again. That's kind of strange. Because again, all that would be is what's underneath. What's my parentheses here? There's my root. There's my exponent. And just kind of keep doing it. But the next part, this has been our nemesis for the entire unit. So what we're going to do, and you've already got a sheet for this somewhere floating around, I would hope. If not, Maybe this is something you might even do at the top of your quiz when we get there, your test tomorrow. Make sure I can fit these in. And all I'm doing is making myself a little chart. Shoot, you could even do this ahead of time and have it ready to go. These are perfect squares that allow us to break these down. We do not want decimals here. If I see decimals on these tomorrow, so like if you wrote 7.9 something, 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 that's not going to work. What we're going to have to do is we're going to have to play around a little bit with these. We're going to look for two numbers that multiply to 63, but one of them has to be one of the radicals that I have up here. And like we've said before, and I'll say it again, if you're not sure, if the multiplication and playing with the factors isn't your strength, that's not a bad thing. You just take the number that's there then and you start trying to divide some of the numbers in. Oops, helps if you hit divide though. Until you find one that goes in evenly. Okay, so when I try 9, it works. It's 9 and 7. So 9 is the perfect one because it's underneath the radical. So you'll always have one that breaks down. Square root of 9 is 3. Gets out of radical jail. New identity. 7 is not in my list. It is still acting irrationally. It must stay in radical jail. And that's all there is to these. Now, sometimes do they get challenging? Yes. 18 is a challenge. It's like, wow, 252. Holy crap. All right, let's try some of the bigger ones here first, because we always want to see, okay, bigger, no, 252 and 64, no. What's that? 36. Bingo. Okay, so notice it took us about a few times. Not a bad thing. So 36 is my perfect. There's 7 again. Not lucky 7 in this case. So my square root of 36 is 6. And then again, the other part won't break down. So when I'm dealing with numbers, that's what I'm going to do. What about if you throw a variable at me? Well, let's see here. Let's take a look at a couple of these guys. We're going to take a look at 21 and 24. Get my variables back down here. Okay, we'll get to the x squared in a minute. We got to deal with the 216 first. Let's see. Any ideas for something to try on 216? I'll even do the work. You just tell me what number to try. 36. Ooh, first time winner this time. All right. So 36, and then whatever answer's left, the 6. So here's how this is going to work. The square root of 36 is 6. Okay, I write that down. Square root of 6 is staying under. But I'm leaving some space this time, and here's why. I have a variable term. And whenever we have a variable, here's how we deal with it. We take whatever the exponent is on it, and we divide it by 2. However many whole times it goes in, that's the exponent that goes on it on the outside. If there was a remainder, and there's not, that would go in here. But since there isn't, that's as far as I can go. And we're going to jump down to 24 because I wanted you to see one that ended up a little bit different. So 24, let's see here. What are my two numbers going to be? 25 and 3. So the square root of 25 is 5. I'm going to leave a little room again here. There's my 3, still acting irrationally. And I look at my x to the third, and I go, okay. So I've got an exponent of 3. I'm going to divide it by 2. It goes in once. All right. Ooh, but this time I've got one left over. So the one that's left over goes inside. And again, if you can't find your chart that we did before to use tomorrow, you always could just jot this down on a piece of paper. I don't mind if you use that and have that ahead of time, that's fine. But just jot those down and do the perfect squares in the calculator. So you're like, okay, that again was more stuff that was forever ago. Now to some stuff that was more recent. Solve each equation. Remember to check for extraneous solutions. That we're not going to worry about as much. But remember with these, get the radical alone. That's my first job. Then I need to square both sides. Stressing the both part. Even if there's not a radical there, you square it. That's going to be the key with these. So even if it's something as simple as 25 is, radicals alone already, and the squared and the square root are inverses. They cancel each other. Oh, moment of truth. What's 8 squared equal? 64. Because remember, 8 squared is 8 times 8. It's just telling you how many times you're multiplying that number by itself. It's not 8 times 2. And that's one of the things I really want to stress. 26, a little different. My radical is not alone yet. How do I get this out of there? Yeah, we're going to do the opposite, and we're going to add it. And I have to do that first. If I square first, I'm probably going to mess this up. And now it's more similar to the last one. Now it's something where I can square both sides. And again, the side with the radical, it just cancels the radical. The other side, I actually get to do something. But I'm not quite done this time because m's not by itself yet. What's my last step to get m alone? We're going to multiply because we're dividing by 7 here, and we do an opposite. So you can get some big numbers. But again, that's not a bad thing. 27, now this, there was one like this on the last quiz, and a lot of you did a step here, but it wasn't quite the right one. So let's see if we can get that fixed here. I need 5v, square root of 5v, alone. What's my opposite this time? How do I get that -6 out of there? Close, and that's what a lot of you did. Here's the difference between this one and 26. Here, that plus minus is in between my radical and this, so it's like I'm minusing 1. Here, there's nothing in between, so I'm actually multiplying the radical by -6. So what's the opposite in multiply going to be? Yeah. So I actually, on this one, I've got to divide. With that negative, it's especially kind of tricky. So that's the one we're probably going to have to be careful of. But once we get that out of the way, then I can go and say, okay, now I'm ready to square both sides and get that out of there. So 5 squared is 25. Those just canceled and left me what's underneath. And now we're into some more normal type stuff where I can just divide by 5 and I'm good. There was one more I wanted to do. I just got to find it. There it is. Okay, number 30. Number 30. Well, wait a minute. You said get the radical alone. There's radicals on both sides. Right, but they're by themselves on both sides. So that's okay. So I'm going to square both sides. And again, the squared and the square root just cancel. Leaves me what's underneath. And now my job's just basically to get the x's to one side. But I do have a suggestion. since the right side just has x terms right now, I'd move my stuff over there. And that's where I can get that last one from, because the rest of them on this page are all identical to ones that we've done with those. So again, it just gives you an opportunity to kind of play, but use the ones up above as examples so we have it good and fresh in your mind come the actual test on this. So let me make sure there's no other ones that were weird. No, that looks pretty straightforward. Might come back to one of those in a minute. All right, flip over here. And as I said before, the test itself is not this long. I just wanted to kind of blend being able to do some with you and leaving some for you to be able to work on too. Sketch the graph of the function. Oh, state the domain and range. Okay. I'm going to do, which ones? Let's see. Do a couple of these with you. All right, first, let's see here. Got my y equals. You might want to make sure, because my algebra tours have been doing some different stuff, if you start getting weird pictures or things, you might want to check a couple of things. One of them is if you hit the window button, your window should look like this. If it doesn't, take a minute, just kind of scroll down and get those values in there that way, because it'll make things a lot easier. The other thing you're going to have to watch for, depending on who had it last, and I'll put up the window thing again here in a minute, is if you hit second and window, this is what that screen should look like. If it looks any different than 0 and 1 there, if it has some funky decimal, we're going to have to fix that. So let me kind of rewind here again. So before we get going, so we're all doing this, looking at the same thing, I'm going to hit window up here at the top, and I'm going to make sure all the values I see on the screen right now are the same ones as the ones that I have, because we all want to be getting and looking at the same picture. So our x min and max, we want negative 10 to 10. Our y min and max, we want negative 10 to 10. Those might be okay. So once you're sure on that, then for my table set, I'm going to use the same button except I'm going to hit second. So second window, this screen should look like this with 0 and 1. This is what I'm concerned with. If some of you have a funky decimal, that's going to make life difficult otherwise. So second window, 0 and 1, then we're ready to graph. So we get back to here, and we do second x squared to get the square root. So let me mark that down. So second and x squared, it's going to get me my radical. And then whatever I want on the inside of the radical, I just type, but then, oops, let's try that again. There we go. But when I'm done inside the radical, I got to close the parenthesis. Because I don't, not plus 2. I want that plus 1 outside. I got to tell the calculator that. So when I graph it, I'm going to be able to tell a few things. We shifted left and up. Left and up. Okay, that makes sense. So then I look and I go, okay, if I get my table, second and graph gets me my table. Remember, I'm going to go looking to see where the error messages start. And there they are. So I'm going to find my values to use. Negative 3, 1. Negative 2, 2. I never should have to use non-whole numbers on these. And I'm just going to look for the ones with values that work nicely. 1, 3. I think we might even get another one here. There we go. 6, 4. And I just turn that out to the right. Once I have that, it says state the domain and range. And if we remember from before, as soon as the error messages start, that is what's telling me where my domain and range starts. Remember, my domain is my x values. My x values are going to start at negative 3, and I see that here, and go off forever to the right, to infinity. My y values, going from the bottom of the graph to the top, my bottom y value starts at 1. So the calculator actually tells me my domain and range starting values. I just look for those values right after error. And then I just plot what's there. But notice, my arrow only is going off to the right. Don't keep going this way, because there's no values there for you to work with. And that's how we're going to do these. So like, let's say I did 39. I'll leave you 38 here. So I get to play one more time. So I'm going to go back to y equals and clear this out. This time, notice the only thing I want under my radical, my second x squared, is the x. The plus 2 is outside, so I had to close the parentheses first. Once I do that, I notice went up a couple. And there's all my errors. So once I quit seeing errors, I start working all of my values. And I'll get as many as I can. Usually I'll get at least 3. I might get a 4th. That's a little off the page, but that's okay. And get those drawn in. And then again, I'm still looking for domain and range. But oh yeah, the chart's going to tell me where everything starts. It tells me the domain or the x's start at 0. And it tells me my range or my y values start at 2. And I'm set. So this part itself is a little calculator heavy. Could I do it without one? Sure. I'd just plug numbers in, hope they came out nice. That would work. But if that's not the case, that's okay. So then I'll leave you with one to work with on your own there. And then we're going to start moving into what we've been doing these last couple of days with our distance and our midpoint. And we'll get you some options on this. So let me do a flip here. Okay, find the distance between the pair of points. Now we talked before, you have options. If you want to use the actual formula, okay, it's subtracting my x's squared plus subtracting my y's squared. So if you've got that and you're like, oh, I can follow a formula, this isn't bad. So let's see, I'd have -1 minus -8 squared, and I'd have -4 minus -7 squared. And we talked before about if you're going to use the calculator, don't use the radical right away. Okay, save the square root. Just do the stuff that's underneath it. So -1, hey, what happens when I minus a negative? Right, so I'm going to do that instead of putting all these negatives in the calculator. So I'm going to do -1 plus 8, and then I'm going to close that and square it. And then I'm going to add that to -4 plus 7 squared. So I get 58. So like, okay, so it's the square root of 58. If I take the square root of that and I get a decimal, I would prefer that you leave it as the radical. If it comes out something nice, cool. I'd go ahead and do that. But if it comes out something weird, I would just leave it the way it is. Well, what if I don't want to use the formula? What if I want to do something else? What if I want to draw a picture? Because you said we could use the Pythagorean theorem, and that's very true. So if I wanted to do that, let's say I tried that on number 2. So if you're more visual and you want to look at the individual points, I just got to be careful that I'm accurate here. I'd plot my 2 points at right 5 and down 4, and left 5 and up 1. I would connect those two dots. That's what I'm looking for. But then I would go ahead and form a triangle between those 2 points. And it doesn't matter which way you go. If you'd have gone over here and then down, you'd get the same answer at the end. But remember, we're talking about a triangle, so we're not going to have negative sides here. So I go, okay. So I go 1, 2, 3, 4, 5. Oh, when the lesson's done, sure. So then, once I get down here, I can count over to there. And again, I got to count the one after it here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So once I have those, I can just take their squares and add them up. So let's see here. Let's get fancy. 5 squared plus 10 squared. Okay. Now, here's where I'm going to push at you a little bit. You're like, okay, let me do the square root of this, and I'm just going to be set. Okay, it's a decimal. Now, this time, though, you're like, uh-oh. I look at it, and if I looked at it for a little bit, I might notice this breaks down. Now, this might be one of those things, if this is a 2-point question, if you just leave it as square root of 125, that's fine. I might get you for like 1/2 of 2 points, which is like nothing. But I could break this down. And I always, whenever I get a radical answer, I always should look to see if I could break it down. Because if I could, I really should. So 25 times 5 is 125. I can actually get the exact answer instead of just being content leaving it as the square root of 125. But even if you get there, that's excellent because it shows me you understand the concept. Formula, picture, I don't care. Yes, ma'am.
For that one, if we just did it regularly, would be right if I just got the square root.
If you had what?
I got the square root.
Something went cuckoo somewhere then. We'll have to take a peek in a minute because, yeah, you should get, whether you use the Pythagorean theorem or this formula, you should get the same answer at the end. So we will have to take a peek and see what is going on. You're like, ooh, number 5, there's like pictures there already. If I wanted to put it back in the formula because I like the formula better, I could figure out what the coordinate points are because I go right 3 and up 5. And I go left 2 and down 4. And I could use those 2 points and plug them into the formula. That's absolutely fine. Otherwise, if they give me a picture, I'm willing to use it. So let's see here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I do it with the picture again, I'm just going to use the Pythagorean theorem. So let's see here. 25 and 81 is 106. I'll be a little helpful here. And that actually isn't going to break down anymore. So I can get my answer that way. But again, I could have used the 2 points there with my formula and gotten the same thing. It's just something to kind of get you some extra practice. And I believe we may have one more thing working here on the back. Yes, we do. I forgot. We almost forgot about midpoint. So last thing working here. All right, the midpoint. The midpoint, remember, is taking your x's and dividing by 2 taking your y's, dividing by 2. In other words, you're looking for an average. Looking for an average of your x's and an average of your y's. So whenever I've got these, I can do them in either order. So I've got 1 plus negative 10, but I'll just do the minus here. And negative 8 plus negative 9, or negative 8 minus 9. And if you want to put the plus in there, you can. And with these, notice I have parentheses around there. We talked a lot about this, where if I forget the parentheses, I'm going to get really weird answers that don't make sense. What do I do if I get negative 4.5? Is that okay? That's okay. Or if you do math enter, the negative 9/2 is okay. I'm good with either when it comes to these. So either one will work for me. And then my last one. Okay, and the negative 8.5 is fine too. Or if you were doing fractions on the first one, negative 17 over 2 is all good as well. So with the points, no biggie. You're like, well, what am I supposed to do if they give me a graph like this? You know, if the line's not straight, I mean, it looks like the middle's like right there. So can I just put a dot and call that the middle? Not necessarily. So here's what we're going to do instead. We're going to figure out what the coordinates are of each point. So I went right 5 and up 4 to get to that one. And here, I didn't go left or right at all, so that'd be 0, but I went down 1. So instead of being given the points, I have to look at the picture and use the points then. So I'm like, okay, so there's my x's. So I have 5 plus 0 divided by 2. And then here's my y's. I got negative 1 plus 4 over 2. And then I go ahead and I just get that stuff done. So 5 plus 0 is 5. So I'd have 2.5. Negative 1 plus 4 is 1.5. And I can get it done that way as well. So take some time here, kind of play with some of the rest of these, because again, the test itself is going to look like this. It's just not going to be as long, but the directions and the types of problems and everything else, that's going to be the same. This will end up being part of the next homework check. So I